Problem 6, a particle is moving on the real line, which really means the x-axis, has an acceleration function of a of t is equal to cosine of t plus sine of t. If the particle is at the origin when t is 0 and has velocity of 5 when t is 0, what is the position function for the particle? Well, we start with the acceleration being cosine t plus sine t, and velocity is the integral of acceleration. And so the velocity is the integral of a of t dt, which is the integral of cosine t plus sine t dt. Now the integral of cosine is sine, the integral of sine is negative sine, and we have to put the plus c there because this is an indefinite integration. But we're told that the velocity is 5 when t is equal to 0. So we plug in t equals 0 and set this equal to 5. We know sine of 0 is 0, cosine of 0 is 1, so we have negative 1 plus c is equal to 5. And here c is equal to 6, so that gives us a velocity function of sine of t minus cosine of t plus 6. Now again, we want the position function, so position is the integral of velocity. We'll call the position function x of t. And so we get x of t is equal to the integral of v of t dt, which is equal to the integral of sine t minus cosine t plus 6 dt. The integral of sine is negative cosine. The integral of cosine is sine, so the integral of negative cosine will be negative sine. And the integral of 6 is 6t. Once again, we add a constant c because we're working with indefinite integration. But we're told that at time t equals 0, the position of the particle is at the origin. So I plug in t equals 0 and I set the entire expression equal to 0 since the x value will be 0 at that point in time. And so cosine of 0 is negative 1. The opposite of negative 1, cosine of 0 is 1, and negative cosine of 0 will be negative 1. Sine of 0 is 0. 6 times 0 is 0, plus c equals 0. So we get c minus 1 is 0. Or here, the constant of integration is 1. And so that would give us a position function of negative cosine t minus sine t plus 6t plus 1. And that should be the final answer to this question.